Hello everybody and welcome. My name is Philippe Ozil and I'm glad today to welcome you to one of the very first Trial Live sessions for this new year. So happy new year everybody and thanks for joining in. Today I'm going to be talking about Lightning Web Components. Alright, and to do so I'm going to be giving you a presentation, but first I need to give you the forward-looking statement. There are a few things you need to know. We are a publicly traded company, so you need to make your buying decisions based on what is commercially available in the product. Now, in this presentation, I'm only going to talk about what is released, so we should be safe from forward-looking statements. Today, we're going to talk about three different things. First of all, I'm going to set up a testing environment. I'm going to teach you how to set up tests for Lightning Web Components. Then I'm going to talk to you about how you write those tests. So we're going to see a couple of notions about file structure, the way you frame tests. And last phase of this presentation, I will talk about best practices, tips and tricks on how to write efficient tests, things you should do to write proper tests. All right, let's start with the testing environment. So when you're testing Lightning Web Components, there's one thing you need to know. You're testing in two different environments, and there's a distinct environment for unit testing, which is not the same as the runtime environment. By runtime environment, I'm talking about the platform. So when you're running your actual Lightning Web Components, generally you're running them on a production org, on a sandbox, maybe a Scratch org, but it is a Salesforce org. However, when you're running unit testing, there's a specific environment which is separate. Testing with Lightning Web Component is done on your local machine only. So this is going to run on your local machine. It's something that can actually run offline. It's not necessarily connected to the internet. And it works with the following bits of software. The first thing that is the key to testing for Lightning Web Components is a Node.js server. This is what runs the JavaScript server, which allows us to mount the tests. Then we have Jest, which is a popular framework. I'll talk more about it, with a couple of extensions. So here Jest is coupled with an extension that we provide, Salesforce provides, adapted for Lightning Web Components. Then we also suggest to use ESLint with a couple of rules which are specific to Lightning Web Components. And since you're using Node.js, well, you're free to add also any other custom dependencies that you would like to run in your test suite. But these are all optional, whether it's ESLint or these other custom dependencies, this is all optional. So let's see a couple of rules on how you run local tests. Well, the first thing is it is actually based on standard practices. This is really pure JavaScript testing. And the great news about this is that since it's standard, a lot of people, a lot of companies have done this before us. So there are years and years of experience with standard JavaScript testing. This means that basically there's a lot of things you can do to fine-tune your configuration. There are a lot of so popular tools which are open source or even are proprietary to customize your environment. We only provide certain features that we offer to adjust the testing tools for Lightning Web Components, but most of them are open and can be customized. Now, another thing that is important to remember is that you're testing on a local machine, and this means that everything you do is has to be done without any platform access. So that's actually something that can sound scary, but it is a good news because it forces you to run tests in isolation. So this is the right way to do unit testing. Often when you're running Apex tests, you're running those Apex tests in some sort of integration pattern because you are actually testing the logic of your Apex code, but you're also testing, for example, database accesses with SOQL queries. Now, you cannot do that for Lightning Web Components. You have only to rely on things that you're providing, like mock values. You cannot connect to the platform. So this is actually the right way to do unit testing in complete isolation with the platform. Now, there are also a certain number of things you need to take into consideration. Because we do not have platform access and because we're running the tests on our local machine, we have to handle the revision control for tests. So we have to basically save our test in some sort of revision control system, whether it is Git, Subversion or any other system, doesn't matter. The tests are never pushed to the Salesforce org. They're only on your individual machine and on the other version control system you really like. Now, there's also one last thing which is very different from other type of testing on the Salesforce platform. There is no code coverage requirement. So why is that different from Apex? Well, the reason is that we've decided that if you make if you have code that has some bugs in your Apex, for example, there's a risk that this will affect data. So you could be messing up with a large amount of data, and this can be catastrophic for your business. However, if you have problems with your Lightning Web Components code, well, it will mainly affect the user interface. So that's, I would say, less dangerous than having bugs in your Apex. So it's up to you. There's no requirement for code coverage, but we're all grown up, so we know what you need to do, and we need to make sure that this code runs for all of your users to make them happy. All right, how do we do that? Well, we use a framework which is probably one of the most popular testing frameworks for JavaScript, that is called Jest. And the reason why it's so popular is that it has a lot of experience. It's been used for not a decade, but close to a decade. And it's super fast. It's able to run tests in parallel. It has a lot of features. So it's able to handle things like asynchronous testing, like when you have timers, when you have complex scenarios. And also, it has an extensive documentation. And this is probably one of the best things you'll experience when running tests with Jest, is that most of the time when you're going to be looking for documentation, you'll find your answers on the Jest website. It's not even something created by Salesforce. You can find your answers on the Jest website. There's a super great documentation site with a very active community, so most of your answers can be found there. We don't have to reinvent the wheel. We can just leverage this extremely efficient testing tool and just add a little extension to make it work with Lightning Web Components. So this framework, this Jest framework, works with vanilla JavaScript, so really basic JavaScript and HTML. And what is specific with this framework compared to others is that it's able to simulate a web page without having a browser open. So this framework replicates the entire DOM tree of your of some certain web pages, and you can perform operations using the web APIs on this virtual DOM tree. It's called JS DOM, and you can do things like call selectors, simulate events. All of that will be just purely simulated in memory. So this can run on your local machine, but it can also run in a CI environment without any screen attached, without having something like a WebDriver or any complex setup. So it's efficient, it's portable, it's great. I didn't mention this, but it's open source, so that means that we can easily create specific extensions for our framework. So we did that for Lightning Web Components, but others are doing it for their own frameworks. For example, there's an extension for React, another one for Vue, and so it's really made of the idea of being extensible. So that's really the key when testing, working a lot with Jest. Now, we did have to provide an extension to adapt Jest for Lightning Web Components. It's called sfdx-lwc-jest. And this extension brings two specific features which are really required to do proper testing with Lightning Web Components. The first thing is that it brings mocks for the base Lightning components. So when you're testing your components, there's a good chance that you have buttons or icons or things that are part of the base components. And since you don't have the source code for these components, the source code of these components resides on the Salesforce platform and you're running on your local machine, you need to have something to replace that. And what the framework does is that it provides mocks to simulate those base components. So each time you have something that is a Lightning component, a base component, you have a mock for that. And the mock takes in account all the events that the base components send and receive. So it's very convenient for testing. You won't see the difference and it's going to make your tests work. The second big thing, which is really important for testing, is the wire mocking utility. Because we're running tests on a local machine, we're not connected again to the platform. So we need a way to simulate data being retrieved from the server, from the platform. For example, if you're calling Apex, well, in your test, you can't directly call Apex, but you can mock the return value of a wire, or you can also mock the return value of a promise. So this mocking utility is a very simple way to compensate for the lack of connection. And it's actually even more powerful because it allows you also to simulate errors in a very simple way. If you're trying to test Apex, sometimes it can be a bit difficult to simulate exceptions or errors from limits, but with the wire mocking utility, it's very simple to return server errors. So this is really what the two key things that this extension is doing, and it's how you can test Lightning Web Components. Now, there are other things which are optional, but they are actually highly recommended for testing. One of them is called ESLint, and this is something called, it does something called linting. What is linting? Well, linting is some sort of syntax verification, and it's also something that helps you validate a set of rules. And these rules generally represent best practices. In the screenshot you have here, this is an example of what linting does when it's integrated with an IDE. So here you can see a screenshot of Visual Studio Code with a linting error. And this particular rule here that we have added, which is specific to Lightning Web Components, checks that we're not retrieving element from their IDE. Why is that? Why is this a problem? Well, when you're doing Lightning Web Components, the IDs are automatically regenerated, so you cannot rely on a static ID like some ID here in this example. So what linting will do is that it will give you some errors about when you see something like that. It also tells you about unused code. For example, if you have variables which are not being used, if you're having unused parameters and functions, that's really helpful. But that works with the component code, but it also is great when you're working with tests. So for example, it can warn you when you have tests which are not checking anything, for instance. So it's not required again, but it's highly recommended. ESLint plus the Lightning Web Components rules. All right, so how do we assemble all of those things? How do we assemble all this environment? Well, it's pretty simple. We need two things before installing the environment. We need Node.js installed on our machine, and we also need to start from a Salesforce DX project. Once you have your DX project, there are a couple of commands that you need to run to enable Lightning Web Component testing. 3 commands to be precise. The first one is called npm init. And you'll notice that all the commands we're running here are run with npm, which is the Node package manager. So what npm is doing is that it's creating a Node project based on the DX project. So it's just going to add a configuration file, package.json file, which contains a configuration for our Node project. Second command here is npm install. This makes sure that we have all of the dependencies. In our case, we have none yet. And the third command is actually adding a dependency to our project. And this dependency is the Lightning Web Component testing framework. So this last command, install at Salesforce sfdx-lwc-jest --save dev, is installing the Jest extension for Lightning Web Components. So it's also bringing Jest, and it's saving all of that as development time dependencies, so not runtime dependencies. Now that you have the environment set up, the last thing here is to actually add a few scripts that let you run the tests. Here I have given you a couple of examples. There are more than that, of course. These are really basic examples, and I will show you that later on when I cover how to write unit tests. And these scripts here can be run with the command line after that. npm run, then the name of the script, and this will execute some commands to run the tests. Either just run all the tests, go in watch mode, which is an interactive testing mode, which checks for changes in your test and your source code and runs only the required tests. And finally, coverage. Jest is able to get you code coverage for your tests. Pretty much like you can do it with Apex, you can also get code coverage with Jest. This is very convenient. So this is how you set up the environment. I'm not going to demonstrate that today for the sake of time, but I'm going to show you how to run those scripts to check and test your code. Right, so let's now switch into how we can write tests. So the first thing we're going to look at is the structure of our test files. Now, remember we are running in a DX project, and the first thing you'll have to check is your line component folder, so LWC. And then the second level where we have hello here is where we have our components. So here we're testing a hello component, and the hello component has a bunch of files and folders in there. The three last files at the bottom of the screen here are the typical files you'll find for any line component. So there's the HTML template, a JavaScript file, and a JS meta file, which represents the metadata of a component. What is new here and what was needed for testing is a folder in that component folder called __tests__. And this is a typical name for the testing folders that Jest will look for. So Jest will actually scan all of your files in your DX project and look for those particular folders and try to run tests in those folders. Now the test files, the last file that you see here at the bottom of the hierarchy, hello.test.js, is a Jest test file. And you can see that it's a test file because of the extension. The .test.js file is getting picked up by Jest here. There can be more than one file, but generally as a convention we try to keep it to only one, and we try to also to reuse the same name as the component to keep track of which test file is for which component. So that's how you structure the test files. Now let's take a look at how we can write those tests. Now remember, before I go forward in the syntax of tests, remember that this __test__ folder is not deployed to the platform. So this is your responsibility to version all of that. Let's now take a look at the structure of our test files. So how do you test those files? Well, there are a set of common structures that are not specific to Jest, but there's first the test suite, which is basically a group of tests. You can consider that as a category of tests. And generally there's one top level test suite that we name after our component. So here it's called hello. And this test suite is a group of tests. So there can be multiple tests in that test suite, but there can also be other test suites inside the test suite. So they can have almost like subfolders basically. This particular suite here has a set of tear down instructions. So these are optional. And you're often going to see that after each teardown instruction, because most of the time when you're trying to test Lightning components, there's a bit of a cleanup to do after our tests. And I'll talk more about that when I get into a specific test as an example. Finally, the last thing which is really important in this particular screenshot here is the test itself. And it's a function called it. There's the name of the test, and then there's a function which actually does the test. And you'll notice one thing here, the way it is written is something called the fluent syntax. And the reason why we call this fluent is that you can actually read this like it's a sentence. It displays greeting. So it's something you can really read, and it feels natural. Of course, there are other aliases. You can also write test to write a test, but this way I think is quite convenient because it feels natural and you can easily understand the test purpose even if you haven't written the test yourself. Alright, so that's the high level structure. We're going to go down now into more details on how we write tests. Now, this particular part of the presentation is a bit more generic than just Lightning Web Components, and I want to draw your attention to this particular mindset. When you're writing proper unit tests, you want to basically break down your test into three phases. The first phase is called given, and this is where you prepare your test. So you're setting up the environment. And in the second phase, the when phase, is the actual test itself. So there can be one test or multiple tests. Generally, it's only one. And finally, there is the then phase. Now, the then phase is really where you have all of your assertions, and there can be multiple assertions. But you're only testing one behavior in a unit test. If you're testing more than one behavior, then generally it's not really a unit test. It can be more like an integration test. So remember these three phases, and given, when, then. And we're going to go now more in details about how you apply these phases to Lightning Web Component testing. Let's start with given. So how do you prepare a test? Well, most of the time it's about adding the component to the DOM and setting a set of public properties. And in this code abstract here, what we're doing here is that we are creating an element for our component. Here, this component is called recipe contact tile, and we're creating that element. It's associated with a JavaScript class. That's what you can see with the second line is contact tile. Then we're setting some public properties. You can see here that we're assigning a public property called contact, and we're using a constant to assign a value. So this is, for example, a property that is exposed with the @API decorator on this particular component, contact tile. And finally, the last line here is that we append our element to the DOM. Now remember, we're not testing in a browser, but we're using JS DOM to simulate our DOM or simulate our web page. So in memory, we are adding our element to the virtual DOM. Later on, we'll be able to inspect that DOM to see if it has the right shape that we expect. So this is the first phase, given. Here we prepare our component, we add it, and we set some public properties. The second phase is the when phase. This is actually what we're going to do to simulate a behavior, to test our behavior. And generally has to do with events. So it can be clicking on a button, entering some text in an input field, or even calling a wire to retrieve data from the platform. So here in this in these code extracts here, I have three different use cases. They're not related to the first one, but let me comment them anyway. The first one is an example of how you can use the mock-based components. Remember that you don't have the real definition of the Lightning button, but you have mocks, and you can use this to get a base component and simulate a click on a base component button. And since the mock is well written, it will simulate, it will call the onClick handler that is attached to it if you have one in your custom code. So this is how you could simulate the click on a button. Another example, which is also using base components, is the second example here, which is using a Lightning input. In this example, we're retrieving the component element. We're setting a value with a constant. So this is a text field. So we're setting a value for a text field. And then finally, we are simulating a change event on our input. And this is really important not to forget this last third line here, because this is what will trigger the re-render, and this is what will trigger the other handlers that are probably attached to the input base component. Finally, the last example, I will show you that more in details at the end of this section. This is how you can simulate data that is returned by the platform. So getContactListAdapter is mapped to a wire adapter, which is probably calling some Apex. And with .emit, we're able to return some mock value, which should be returned by the platform, maybe by our custom Apex, for instance. So this is how you test the behavior. And finally, the last and final phase is the then phase. This is where you write your assertions. Now, Jest is very, very interesting because it's also using a fluent syntax again. And the value of this is that it's very easy to read those assertions. Even if you do not know Jest yet, I think you can understand what these three different examples are doing. It's something that you can really read out loud and you can understand very easily. So I'm just going to read out one for the sake of the demonstration. You can see the last one is expect error panel element not to be null. And you can see this is written just as a natural sentence. I can really understand that. Now, the assertions are built in two parts. First, there is an expect element, which is an expect function, which is taking an input a value or an object. And then there are a set of matchers that are doing some checks on this particular element or value. Now, the matchers can be combined, and there are a lot of them that are part of Jest. All of what you see here is just standard Jest testing. There's nothing that is really specific to Lightning Web Component in this set of matches. Everything here is really standard from Jest. So that's really powerful. Now, before I talk about the common patterns and the best practices, I'm going to jump to a quick demo. And I'm going to be talking about how we use tests and how we run them. For today's demo, I'm going to work with one of the sample applications. So I'm going to use the recipes application. This is available on Trailhead, and there are multiple sample applications that we provide that are open source. Today I'm going to look at recipes, but there are others. The recipes here is the one that is showcasing a non-platform version of the project, but there's also an off-platform version of the same project. But what is recipes? Well, recipes is a set of easy-to-digest code examples which are very specific use cases like conditional rendering, iterations, child-parent communication. And you can see very, very small examples, which are 30 lines of code max, which gives you very specific recipes, basically. And all of these recipes have also test files which are running with them. So I'm going to use that as an example to show you how Jest works. And you can see later on, compare the recipes on platform and the open source version which runs off platform, and you can see that the same test code is being used on both projects. Now, before I jump into recipes, I just want to show you that we have also other sample applications that you can get from this particular web page. There are also e-bikes, Dreamhouse, a lot of other examples which are more business oriented, which are more advanced demos that combine multiple features of the Salesforce platform. So today we're not going to look into all of these, we're just going to focus on recipes. Now I'm going to switch to my org here, which has the recipes installed, and if you look at the website, you'll find a link for the GitHub project with instructions on how to install this. And we're going to look at our recipes. Now, notice that there are a lot of different tabs here, and we have basically used those as folders to regroup related recipes. I'm going to start with a very simple category here, the hello category, which is just, for example, showing a simple hello world. There are more advanced examples with conditional rendering or iterators to show lists. But I'm going to start with the very first element, which is very simple, hello world. So what this is doing right now is showing up a property here, world here, which is mapped to a property. And I'm going to look at the code now, and I'm going to see how this works. So this is the source code for our hello component. And we're looking at the template of our component, and you can see hello world is basically displayed here. And it's using a property called greetings to display the value of world. The JavaScript is very simple. It's just a greeting attribute that is mapped to something. Now you'll notice that I have written Trailhead here. The one that you saw on the org was hello world. And the reason why I changed that is that I made some changes to break my tests. So let's take a look at our tests. So this is the hello folder in our DX project. We have the components files we saw before, and there is this __ test folder here, which contains the code for our tests. Let's take a look at the test code. Now, the test code is getting the component itself, and it's creating a test suite called hello. We have a bit of cleanup here, and I'm going to take a second to explain a bit what this does. Now, each time you test a Lightning Web component, you generally want to create it and attach it to the virtual DOM. The problem is this virtual DOM is shared across multiple tests. So what you want to do after each test is basically make sure that you remove all of the elements that are present in this virtual DOM. And this bit of code here is checking for any element and removing them one by one up to the point where the DOM is completely empty. And this is when we're ready to chain the next test. In this particular instance here, it's not really important, doesn't really do much because there's only one test. But you can imagine if there are multiple tests, you don't want different test results to leak into the next test. So this is why you're running this cleanup logic after each test. All right, so let's take a look at our test here. It displays greeting. What this does, it has only two of the three phases here. It's the given and the then phase. There's no when because we're not actually simulating any interaction. We're just doing a test with rendering. And what we're doing here is creating the element, attaching it to the DOM, and finally we're going to inspect the DOM to make sure that we have the right output. Now you'll notice that here I have left the original version of the test here, which is checking for world. And in our markup, in our JavaScript file, we were actually injecting trailhead. So our test is broken right now. If I run my test, we'll see that it's broken and we're going to see an error. So here on the there, we have a terminal which is running our test. And in a second, we should be able to see the results. There we go. So the test failed. It took a bit of time, but here we can see a precise output of what happened with our test. I showed you how you can run the test directly here from the IDE, from VS Code, but we can also run tests from the terminal. I'm going to show you that next. So you can see that the statement was expected something and we received another thing. This is pretty easy to understand. Now, how can we fix that? So I'm gonna clear my terminal for now. Oops, sorry. And I'm gonna run another command here, and I'm gonna run the watch mode. Now, the watch mode is very powerful because you can run this watch mode in parallel with your development, and you can basically run tests in parallel as you code. So here, the watch mode detected that my test file has changed. That's because I made some modifications earlier, so it's still fading, that's fine. But it will constantly watch for change in my test files as well as my component files. And each time it will detect some changes, it will figure out what needs to be rerun in terms of tests. So here, for example, I still have my error here with my wrong output. So I can just change my test here to correct the settings. And as soon as I'm going to save my file here, it's going to rerun the tests in my watcher. And you can see here I just saved. It's running again my tests, and it will find that my test is fixed and everything is passing. There we go. So here is how you can run the watch mode. And one last thing I want to show you before moving on is the code coverage. So just like Apex, we can request a code coverage analysis. And this will run all the tests. So here there are quite a few. It will take a bit of time because I have more than 100 tests that are being run. What you can see here is that it is running a lot of tests in parallel. I think it's running 10 tests in parallel. All of that is configurable, of course. You can run more tests in parallel. And at some point, it's going to build a coverage report and it's going to output the results of our code coverage. And that's it. The table you can see here is the code coverage for 152 tests that ran in 67 suites. So let me go up to the bottom and talk about what these metrics are. So first of all, here we have the overall code coverage for the project, 76%. And we can see the number of lines that are covered. Now, if you drill down into specific tests, you can also find the lines that are not covered by those tests, the things that are missing. So it's easy to figure out what is wrong with our test and what needs to be added. All right. Before I finish the demo, I want to show you one other component which is a bit more advanced. So we saw hello, which is very simple, and I think it highlights it's very easy to understand, but I'm going to jump into something more advanced, and I'm going to jump to an Apex, a code that calls Apex. So I'm going to show you again the org here. We're going to switch to the Apex tab here, and I'm going to show you this particular recipe here called Apex wire method with params. What this does here is a basic search feature. So it's an input box which allows us to search for a specific contact. So if I type Amy here, oops, yeah, capital also works, Amy, it will filter on Amy. And this is actually doing a SQL query in Apex, which is searching for a list of contacts that is on our org. This is not just hard-coded data. So how do you test that? Remember that you don't have access to the platform. So let's take a look at how we test that. So before I jump into the test, I'm actually going to check the source code for a component. This is our component here that you just saw. There is the input here, which lets us search. And here we have the iteration which displays the filtered list of contacts. Let's take a look at the JavaScript. So we are actually using an Apex function here called find contacts, which is part of the contact controller Apex class. This is what we're going to be calling in a wire call here with a parameter called search key. The search key is basically the output of the text of the input we're typing in. Now there's a bit of logic here, which is basically adding a little delay for the typing so that we don't run a lot of queries when we're searching for quickly typing basically. So each time you type a letter, you're not doing another search, waiting a few seconds before doing the search. But that's not really relevant for a test. You can just ignore that. What is really important here is this particular block of code. This is how we're calling find contacts with a parameter called search key. Now, I can show you quickly the Apex code, which is very simple. This is the method that is being called, find contact from the contact controller class here with the search key parameter. And what it's doing, it's simple. It's just a so-called query with a filter on the search key. All right. So how do you test that? Let's now take a look at the test folder for a component. Now you'll notice that there's also a subfolder called data here. And we've used this subfolder here to store mock data. So we've prepared two mock outputs for a contact controller call. The first one is showing some data with just one contact, which is simulated as a JSON file here. So this is really the structure of a contact record that we could have with a fake ID. And we have another JSON file here with no record, so it's an empty array that is being returned. Now, these two files are very convenient because these lets us extract or sample data that is being used for tests and lets them separate them from the actual test code. Let's now take a look at the test code itself. So there's a lot of things going on this test file. I'm not going to show you everything. I'm just going to focus on one particular test here, which is probably the easiest to understand. It's how do you test that you have the proper output when you're testing, checking for one record. Now, what this is doing here is the same thing as earlier. So we are creating our element, adding it to a virtual DOM, then we're simulating an input. So we're simulating the user typing Amy in the search field, just like I did manually before, and we're sending a change event. Now, there's a bit of code here which is specific to Jest. We're actually running all the timers. So remember when we were looking at the JavaScript code, there was a timeout which was preventing us from doing too many searches. And with that particular call here to Jest function run all timers, we clear out those timers. So we force the component to directly call the Apex code. Now, the next thing we do here, that is part of the test, is calling the find contact adapter. So this is not something you wouldn't have normally on your runtime code. And let's take a look at where this comes from. If I go back up to the top of the file here, we have a few things that we have imported. We have our component, which is imported here, and then we have also a function here called register apex test wire adapter. And this is what will let us simulate actual wire calls. And this is the same wire call that we had on the production code, on the platform code. So what we're doing is that we are creating a mock of the real wire call here, and we're returning that mock as find contact adapter. So this is really a mock of the wire adapter. Now we're also doing two things here. We're also importing our mock data from the JSON files that you just saw earlier. And this is what we're going to be using to return the mock data. So back to our code here. What we're doing here is that we're calling our mock wire here, and we're passing in the JSON file which contains one contact record. And this is how we simulate data being returned by the Apex wire. And we can pass in whatever we want. We don't need to create the records and insert them like if we were doing Apex. It's just in memory, it's mock data. And you could do the same thing to simulate errors, by the way. So we're sending that data. And finally here, there's the last bit of code here, which is actually the then part of our test. This is where we have the assertions. Now you'll notice one thing, it's wrapped in a promise. The reason why it's wrapped in a promise is that we need to wait for an asynchronous re-rendering of our component. So you have to remember that when you're calling the server, we're getting back a result, and then when we get this result, we inject it in the template. So we need to have a bit of time to re-render the template. And this promise.resolve is actually doing that. It lets us enough time to re-render the component on the virtual DOM so that we can do our tests. So what we're doing here is that we're checking for paragraphs, all the paragraphs, and we're making sure that we have enough paragraphs to cover all of the elements in this find contact JSON. So there's only one here, but it needs to match the data from our JSON file, which is also one. So this is how we're testing the output that is being presented in the virtual DOM and checking that it matches what is in the JSON file. So if I add another record in my JSON file, this test code will also work. We don't need to modify the test code, we just need to modify the test data if we want to. Alright, that's it for the demo. I'm going to go back now to the slides, and I'm going to finish with the third and last section of this presentation. I'm going to talk a bit about common patterns and tips, and a lot of these things that I'm going to cover now are also relevant for testing, whether it is Apex or any other technology. These are really good practices. So the first thing that is really specific to Lightning Web Component here, and the rest is really more generic. When you're doing tests in Lightning Web Components, you're mainly doing two types of activities which have different constraints and different goals. You can either be doing DOM inspection and logic tests. Of course, you can combine them, but these are really two different things. They're all written in the same structure of testing, but they're really different goals. Now, when you're doing DOM inspection, you're basically testing the template of your components. You're testing the DOM of your component. You're making sure that it renders correctly, and you're also making sure that it catches and fires the right events, so that if you have parent components, they will react to the right events. So DOM inspection is already required because this is checking if the UI behaves correctly, which is what is basically the most important to your end users. But there is a few drawbacks to it. The first thing is that DOM inspection does not count towards code coverage. So when you're doing coverage, you are not checking for conditional rendering, for example, or for iterations. This is not taking into account if you have template, if true, then a condition. The Jest framework does not detect that as something it needs to test. The Jest framework is going to calculate test coverage only for logic. So it's going to check only the JavaScript files. So you have to figure out all the possible scenarios, and it's up to you to figure out if you have left any blind spots which are not tested. Another thing that is also something to keep in mind with DOM inspection tests is that it's harder to maintain. Often when you're doing tests, you are checking things against the structure of the DOM tree. So you may be using CSS classes as hooks to do query selection, or you can also do query selections on particular types of elements like paragraphs or divs. But if you change your template, at some point there's a risk that you break your components. And the most risky part is, of course, the CSS tests. If you do any changes with your classes, there's a chance you break your tests. You have to keep that in mind. Now, finally, the logic test is really, I would say, the most commonly the most common testing that you can run with Jest. It's basically checking your JavaScript logic, making sure you have the right logic with your conditions, your loops, and everything, and also the proper wire calls. So when you're retrieving data from the server, you want to simulate the different scenarios, successful responses, error responses, and all of that is going to count towards test coverage. So it's easy to do, it's easy to keep track of what you have missed here. So you'll need to do both, and you of course want to pay attention to DOM inspection, because really that is what people are seeing at the end results of your tests. Now, some more generic rules which are true for any kind of testing. there are two things you have to pay attention to. The first thing is how you name your suites. Generally, I recommend you have the top level suite as the name of your component, and then you can have other sub-suites then, like we have in this example here, which are covering specific group of scenarios for testing. So in this example, the first level suite is called Apex, with the name of the component, Apex wire method to property, and there's a sub-suite here which is checking the wire calls with get contact list. Now, this can contain, of course, more than one test, but the idea is that we're grouping tests which are related to wire calls in this subsuite. We can also have another subsuite which will be checking for rendering, for example, with conditional rendering. Now, finally, for tests, you want to make sure that you have a sentence which describes the scenario and the expectation. So under what condition will you expect something? And again, it should be readable as a sentence. So this is another great example here. It renders no items when records are available, where no records are available. Expectation and scenario. This is really a good rule. And the idea here is that when the test fails, you want to make sure that anybody can understand what is failing. Even if the person hasn't written the test, with the name of the test, they should be able to understand precisely which component is failing, under which condition, and what was expected. That's really the idea here. When using testing data, there are a few things to know. Well, I really suggest that you use realistic test data. So don't do foo bar or things like that. Try to use realistic variable names, especially if you want to look for persons. You want to check names of persons which are close to reality. Of course, I wouldn't suggest you try out with real production data, but something close enough would be good. You also want to use a lot of constants, and you want to place generally those constants at the module level, so at the top of your JavaScript test file, so that you can easily change those values without having to scroll through the entire test file to figure out where those constants or values are being used. Lastly, we saw that in the Apex tests, you want to move your test data to JSON files, especially if you have a lot of test data and complex structures. You can move that to JSON files and import them very easily with one line of JS code. So that's something to keep in mind. Don't clutter your test files with a lot of sample data. You can easily extract that in specific files. A few more best practices. You want to focus on black box testing first. So what does that mean? Well, black box means that you're testing a component, but you do not know, you're going to pretend that you do not know how the component is implemented. So you're going to test things that are visible from the outside without knowing the specific implementation details, basically. So what this means is that you want to try out everything that is public methods and attributes. You want to make sure the template is correct, what's the UI, what the user sees, and the events that are coming out of your component. So if you click on a button, you want to make sure that your component bubbles up the specific event that the button has been clicked, for example. Now, what is important to keep in mind is that when you're doing testing and you're working on a large project, you do not need to reach 100% code coverage. This is probably not needed. If you first try to test which is public, there's a good chance that it will also test your underlying helper functions, which are hidden deep down. So make sure you do test first what is public, and you can differ a bit the rest. You do not need to test everything at 100% code coverage. All right, so it's now time for me to conclude. What we've seen today is how you can do local testing with Jest. We saw the configuration of the project, how you can run the different commands. We also saw a reminder how to write behavior-driven tests. Remember the given, when, then phase. 3 different phases with each of them specific goals. We saw also some Jest extensions, Jest syntax to write tests and matchers. And finally, one last piece of advice, again, that I just gave you in the slide before: focus on black box testing. This is focusing on the user interface, on the behavioral component, without watching too closely how the component is implemented internally. That's really my piece of advice here. Now, before I finish the session here, I want to give you some overview about the next steps or things you could do after running your tests. One of them is adding Prettier to your project configuration. We saw that we can enable a Node.js configuration for a project. We were running Jest for tests. And we were also suggesting to use ESLint to do syntax verification with rules. And what I'm suggesting here in this particular bullet point here is to add also Prettier. Prettier is a code formatter. And what it will do is that it will apply a standard syntax rule to your code. And that's actually pretty convenient when you work with a team of multiple developers that are collaborating on the same project. Prettier will make sure that your code looks completely consistent across the repository. So even if people have different coding styles, Prettier will rewrite all of that with a standard unified syntax rule. Now you can configure the defaults, but the defaults are very powerful and make sure that you have the same rules. Some examples. Well, for example, people have preferences at whether they put spaces or tabs for indentation, or whether they put opening brackets on the same line as the functions or things like that. And Prettier has a set of built-in rules that you can easily customize that will apply one unique code style for your whole project. So that's really powerful. And combine that with the second point here, setting up continuous integration. You can actually move Prettier inside your continuous integration to make sure that the code always looks consistent, even if there's a new PR. And you can run all of those tests in a continuous integration system. Now, if you look at the recipes sample application I showed you earlier, there's setup instructions, and we are running all of that in a continuous integration system. So you can look at the configuration of how we set up continuous integration for the recipes project. And we're doing that. We're also using Prettier, we're also using CI. And in the context of recipe sample application, this is the CI system is running on GitHub Actions. So you can take a look at this new CI system that was recently released. And one other thing to consider when you're moving forward with your project, if you have set up tests and you have a great code coverage and you're happy with it, don't stop there. You want to make sure that you monitor how your code coverage evolves around time, because you're going to add a lot of features, and also people are maybe going to add features or things on your org. So you want to make sure that you keep track of your code coverage and make sure it's always with a decent level. So you want to set up a target, and you want to make sure that this target is this goal is always reached. So monitor it over time. So how do you do all of that? Well, I'm going to give you a few resources before really finishing this session. The first and most useful thing that you want to check is the Jest website, because as I mentioned earlier, there is a really broad range of examples and documentation for all kinds of scenarios. So whether it is asynchronous testing, whether it is simulating timers, or just all the different matches that you can combine, all of that is documented on Jest.js. Now, there are a few things which are very specific to Salesforce, and you can find them easily when you look at recipes. So you want to check out the sample app gallery, and you want to download maybe recipes to check out how the recipes are being tested. And you'll find scenarios on how to test, for example, the wires, which are very specific to the Salesforce platform. Finally, you can have also some other interesting resources on our blogs and on the Trailhead platform. Now, for now, there's no unit that is specifically dedicated to testing. That's probably going to come in the future, but just to be transparent with you, we'll have to wait a bit for specific content on testing on Trailhead. But there's a lot of content on how to write proper Line Web components, so that is still valuable. With that, I'd like to thank you. I hope you enjoyed this session and you learned quite a few things. And stay tuned, because there's going to be a lot more content coming up on Trailhead Live. Thank you again.